This guide will show you how to create conditional forecasts and verify the plausibility of the forecasted parent and child relationship. Click the Adjust button on the ribbon. Select XOM as the node ID. This shows the forecasted conditional probabilities and expectations. Similar to the default unconditional forecasts, the defaults are set equal to the historical values. This table is populated using a combination of historical data, statistical concepts, interpolation between existing values, and best guesses. Note, you should only forecast expectations when the corresponding probabilities are non-zero. Otherwise, your forecast will never be simulated. After assigning values to each probability and expectation in the table, click the Adjust button to store your forecasts in the database. This will enable you to easily access them later if you decide to alter your estimates. To complete the analysis, you should forecast conditional probabilities for Google as well. The Evaluating Forecast Guide will show you how to measure the accuracy of your forecasts so you can learn from them and improve in the future. After you've finished entering your forecasted probabilities and expectations, save them by clicking OK. You should use the same unconditional analyses shown in the Creating Unconditional Forecast tutorial to verify that the conditional forecasts create reasonable simulated returns. As mentioned previously, you should also analyze the connections between nodes. This section will show you how to analyze these connections for simulated data based on the conditional forecasts. Click the Node button on the ribbon. Click Conditional Statistics. Select XOM as the node. Click the plus next to Validate Conditional Probabilities, Validate Conditional Expectations, and Regressions to expand them. Similar to the unconditional statistics, you can view each of these analyses within the context of the network as well. As with the unconditional probabilities, the validate conditional probabilities are calculated using the simulations, and therefore differ from the forecasts. In contrast, the validate conditional expectations are exactly equal to the forecasted conditional expectations. This occurs for the same reason as for the unconditional forecasts. The simulated returns consist of the forecasted conditional expectations. For example, if a simulated U.S. market return is a large loss, and the simulated Exxon return is also a large loss, then its value is set to negative 3.5%. The validate regression results are similar to Explore. The beta of Exxon to the U.S. market is 1.03 compared with a historical value of 1.1. In other words, the forecast is for Exxon to be slightly less sensitive to the U.S. market in the future. The validate R squared, which is the square of the correlation between Exxon and the U.S. market, is 0.436 compared with 0.57 for Explore. This indicates the forecasted correlation is similar to the past. Click the Node button on the ribbon. Click the Time Series button. Select XOM as the node. Click the plus sign next to Rolling Correlations Charts. Unless you expect future correlations to drastically increase or decrease, the validate rolling correlations should fall within the same range as the explore values. In this case, the explore 30-day correlations range between approximately 0.44 and 0.86, and the validate correlations stay in that range for most periods. In summary, the exon validate connections are similar to the explore ones. You should also verify that the exon validate unconditional statistics correspond with your views. After you repeat these analyses for the rest of the nodes in your model, Google in this case, you are ready to analyze and optimize a portfolio consisting of the bottom nodes in the network. The portfolio analysis and optimization tutorial will show you how to do this.